So guys, the C programming language is so raw that we don't even have any checks for arrays when we're setting indexes like you would in Java. This allows us to actually overflow in memory and change other variables in our program. This is a great example of this. You can see here we create an array of 4 elements. And index 0 is 20, 1 is 30, 40, 50, so on. So the final element is 50, and then we create this temporary variable, and the value is 122. But then look what happens when we overflow the array. So we can obviously only access 3 indexes, right? But here, if we access index 4, we set it to 90. We actually change the temporary variable. And this is because of something called a stack frame, okay? So the C compiler arranges assembly language in such a way to store all these values on the stack, okay? And the temporary variable is stored directly after the array. So when we actually access array 4, which is an invalid index, we overwrite temp. And this is just the nature of how C works. It's designed this way because you can point to hardware addresses in memory and so on when you're doing firmware and kernel development. So it's a very powerful language, but you need to be very careful because, yeah, if we run that program, look what we see, 90. But we know temp is not 90, okay? How crazy is that? So you've learned something today now. So what I've demonstrated here can actually be exploited in the wild, right? If we had some sort of input and we were saying which index do you want to read and someone manipulated it, they could read data they wasn't supposed to, right? Or in really bad cases, they could overwrite data that they are not supposed to, okay? Buffer overflow attacks are extremely dangerous, and, especially if you have a network application, because someone can manipulate your program in such a way that they could take control of that program, okay? They can inject machine code into some sort of buffer using this type of attack, okay? And then they can overwrite the return address, which will be on the stack frame. So it jumps to that code and executes it, okay? Now, in modern day and age, there are certain protections in place, but it's still very exploitable in the wild. So this is a very dangerous software security bug, okay? This is not Java. In Java, you'll have some exception thrown here. This is C. Okay, the machine code it generates does not check for these out of bounds conditions, okay? So you need to be very careful, okay? Now, to make this work, I did have to compile this program using some special flags, which I'll show you. So I had to turn the stack protector off, which helps detect these sorts of issues at runtime. And I provided this flag as well to omit the frame pointer. Also disabled program independent code. And we put the optimization to 0. And we did the optimization to 0 so that it didn't remove any unnecessary code in here, okay? And then that might have not given us the result we wanted. So there are some basic protections in place, but you can't rely on it, guys, okay? This is incredibly exploitable. Now, if you want to learn C programming and how amazing C is, then check the related video where you will learn how to program the C programming language for free. My course is free until the end of 2025, guys, okay? So check the video description for the related video where you can learn how to do that, okay?